Welcome to the future. PBS Digital.
125 million miles away, a traveler is taking pictures for the folks back home.
Look at that!
They've waited years for this moment. Their baby, the rover Spirit, has just landed safely on Mars. And Opportunity, launched 3 weeks later, will be there soon.
This is a big night for NASA. We're back.
They've come to Mars to answer a question that's intrigued scientists for decades. Was this ever a place that could have supported life? Did it have the liquid water that life requires?
This is a complicated planet. We haven't gotten it right too often. We're going to be in for more surprises.
Tonight, Nova goes behind the scenes on an expedition to Mars, to places no one has ever seen before. Follow the explorers as they close in on the secrets of a planet that's killed more than half the missions ever sent there, and nearly killed this one before it began. 2 weeks after landing, Spirit reached out to investigate a Martian rock for the first time. Everything was working perfectly. And then suddenly, Spirit went silent.
You're not seeing any signal at this time?
Negative.
All at once, the party was over.
We now know that we have had a very serious anomaly on the vehicle.
Right now, we just don't know. We do not know what caused it. Was it something that we did?
By our inability to receive telemetry.
There's some vulnerability in the design that we didn't know was there.
For AIM Odyssey pass, received no data.
Did we have some kind of hardware failure? Something broke?
Data on the normal direct to Earthlink session.
Was it an act of God?
There is no one single fault that explains all the observables.
I mean, it could be any of those things.
Meanwhile, Spirit's twin, Opportunity, was about to arrive.
Every time we do an intercept landing, it's another experiment that may or may not work. And I have to admit, I did not sleep very well last night because this is exactly what's going on in my mind. You know, what if we had 2 disasters on our hands? I mean, all this wonderful excitement, and suddenly we would lose everything.
4 years of work, $850 million, careers, reputations, and the future of planetary exploration on the line. Welcome to Mars, right now on Nova.
Major funding for Nova is provided by the Park Foundation, dedicated to education and quality television.
Science. It's given us the framework to help make wireless communications clear. Sprint is proud to support Nova.
We see one small step on Mars. Microsoft is proud to sponsor Nova for celebrating the potential in us all.
And by the Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you.
The rover Spirit is 125 million miles from home. Whether it's alive or dead, no one knows. At NASA's Jet Propulsion Lab, mission controllers have lost contact with their $400 million robot.
The station is confirming that they're not seeing a signal at this time, but they're still looking for it.
Copy that. If you give us...
Spirit was about to make its first measurement of a Martian rock, when suddenly the signal dropped out.
As far as my displays are concerned, I can't see anything. They're not picking up any signal.
A few hours later, they heard 2 beeps in response to the question, "Are you alive?" That was yesterday. Now, they can't even get a beep.
We haven't gotten a beep yet.
So far, they have no idea what's wrong.
Sir, at this time, I have to report that we do not see any MER data. Okay.
All they know is that they have a sick rover, a long way from home.
You know, when you get these pictures back, you really feel like you're there. It feels like a walk in a summer day in the desert. But suddenly, when a vehicle stops talking to you, the vast distance between Earth and Mars feels really, really apparent, and it just terrifies you that maybe that tenuous link that you thought was so strong suddenly is broken.
Until now, the mission had been a triumph for NASA and the Jet Propulsion Lab, where the rovers were built. For more than 2 weeks, everything had worked perfectly.
I don't want to speculate with the team.
Spirit was an international celebrity, in the news almost every day. With the risky airbag landing safely behind them, the most anxious moment came when it was time for Spirit to drive off the lander.
We've got the vehicle completely deployed, ready to go, and now we're going to be sending it off onto this big first step. To put it bluntly, to screw up that step would have been a tremendous disaster.
They would have preferred to drive off straight ahead, but part of the airbag was in the way. Rather than risk getting tangled up, they used the test rover in the Mars sandbox to practice a tricky move. A turn in place on the lander so they could drive off in another direction.
It's like your first child. The first time through, everyone was kids gloving it and nervous at every phase because, you know, the world was watching you. Spirit was tough. Spirit was a sleepless, tough time.
Charlie Tango _ Romeo 21906 decimal alpha decimal 00.
Finally, it was time for Spirit to take its first big step.
Is the most significant 3-meter drive in recorded history.
Setting on my mark. 3, 2, 1, mark.
We're essentially just pushing a button and sending it off on a 3-meter journey and then finding out later if it worked. Very, very stressful.
Thumbnail, the lander in the background.
90 minutes later, Spirit sent back a picture of the empty nest. With 6 wheels on Martian dirt, the most dangerous phase of the mission was over. The time had come to start exploring Mars. This is what everyone had been waiting for. And then Spirit stopped talking.
They did not see any sign of signal from the lander.
Oh, we didn't see anything.
Okay, copy that.
The next day, when we didn't get any communications down, there were people sitting there saying, oh my goodness, this thing might not ever work. And then all of a sudden, when no one was expecting it, it started sending down data.
Flight station reported that they're seeing signal at 143536 on all the downlink channels. Great news. Let's see if we can look up to it.
We got what appeared to be one of the messages that we really wanted to see. But as we went through it, and with the crowd of people around us, it became fairly obvious that it was just a really unfortunate piece of garbage data.
We're going to look at some more, but it doesn't look promising.
But even garbage is better than nothing.
I was thinking, at least it's trying. So now we have a chance.
Tracy Nielsen is the fault protection engineer. She helped design systems that put the rover in a safe mode when things go wrong.
What they do here at JPL is they build a lot of robustness, a lot of fault protection capability, a lot of ability to keep the vehicle alive into the hardware. And what that does is it buys time. It buys time for some very smart engineers to go through the data and figure out what the hell happened.
We're thinking there's a problem with the software, and so...
They have lots of theories, But until they get some real data from the rover, they can't diagnose the problem.
Get the same thing, so give us a minute.
Copy that. Just want to understand. Thank you.
There's a lot of pressure with get us the answers right now, and people 24 hours a day asking us what's going on, and we couldn't tell them anything.
An hour later, they try to get Spirit to talk again.
Copy that. 63.
And it did start talking to us, and it was great. I mean, everything looked perfectly nominal. We were cheering. And then it sent the same data again a minute later. And then it sent the same data again. And then it sent the same data again. And then it sent the same data again. And we're like, oh, it's like Groundhog Day. No. And then the signal dropped out.
Just when Spirit seems to have lost its mind completely, it calls home again.
Fault monitors, so 72 monitors.
And finally, there's some useful information. Spirit's computer has tried to reboot 66 times in the past 2 days.
Copy that.
When a computer crashes on Earth, you can press the reset button and start over. But when Spirit crashes, there's no one there to press the button. So it's programmed to reboot itself. And that's what it's been doing, over and over for 2 days, without shutting down at night to conserve its batteries.
So when it's supposed to be asleep, the thing was awake for hours, thrashing around, doing we don't know what during the night. And the battery is getting, the power system is getting pulled down lower and lower and lower. The vehicle is not designed for some of the things that it was going through.
Sure, clear to command. Copy flight, radiation on my mark, 3.
They send a command to shut down, but it doesn't work.
I wasn't even sure if we were going to make it. We didn't seem to be making progress in getting control of the rover, and if the battery just kept going down, we could have lost it.
As night approaches, the unhinged rover is still wide awake. The automatic fault protection should shut things down before the power system is damaged. But it may not work in this crippled condition. With the rover on the dark side of Mars, the next chance for contact is 19 hours away, if Spirit survives the night. Work continues at JPL, searching for a common thread that links all the problems they've seen.
Change the ball, how fast we're putting data in the pipe.
Everyone could use some sleep. They settle for pizza.
I went one day where I went 27 hours here at work. There's always one more thing to look up, one more thing to check. So even if you do go home, you can't really sleep.
Tracy spends this night working with the test rover, trying to reproduce Spirit's puzzling behavior, while the rest of the team pursues other leads. By morning, they have a suspect. The flash memory, Spirit's equivalent of a hard drive, where the computer stores data when the power is off.
And as it turned out, there was a way, which we'd used in test, to isolate flash memory and keep it out of the picture altogether.
Flight mission, your go.
Still not knowing if Spirit survived the night, they send the command to restart without the flash memory. Nothing happens. But there's a good reason. Spirit is asleep. The fault protection worked, pulling the plug during the night, probably saving the rover's life. Later, Spirit wakes up and receives the command.
Flight Ace, we've locked on telemetry 145414.
And it works.
We have partial control of the vehicle.
Even so, without the flash memory, Spirit can't do much. And they still don't know what's causing the problem.
We are a long way from being out of the woods. It's going to be quite a while before we're doing science with this thing again. But we have got a way of talking to the vehicle now so that it responds appropriately. It has regained its sanity. And that's a good feeling.
And not a moment too soon. Opportunity will be landing on Mars in just a few hours. Saturday night, January 24th. It's showtime at JPL. At 8:59 p.m., Opportunity begins its plunge to the surface of Mars. Spirit's crisis was a blunt reminder of how quickly things can go bad.
We are now at an altitude of 73 miles.
And landing is the most dangerous moment they face. A nerve-wracking 6 minutes of automated parachutes and airbags that must work perfectly to work at all.
If you go for that full emotional roller coaster ride, you're history. I mean, it is just emotionally too hard to take over and over and over again. Though this is an exciting ride, you know. If we get this vehicle down the surface of Mars, we'll be very, very, very happy.
The spacecraft is bouncing on the surface of Mars and rolling around. The antenna is pointed in many different orientations.
Guys, LCP, we see it on the LCP.
We're seeing it on the LCP.
To EDL.
The landing team is feeling especially good tonight. In the space of 3 weeks, they've beaten Mars twice.
There's actually 3 things we need to do here. 1, drinks. 2, take a picture. And 3, go together to the press conference.
For 3 years, delivering the rovers safely to Mars has been the focus of their lives. Now their role in the mission is over. Almost. The press room is already packed with reporters waiting to hear from NASA's top officials. But this is an irresistible force. These engineers are now the world's leading experts at landing on Mars. Many of them are already at work on future missions. But this one will be hard to top.
All of us on the EDL team acknowledge that this is the greatest experience of our professional lives. So there's a lot of separation anxiety. That's what we're talking about. You know, how can anything match this?
To the Mars Exploration Rover team, the best in the world.
Spacecraft have been visiting Mars for more than 30 years. From orbit, they've seen ancient floodplains, dried up lake beds and river channels. Strong evidence that this now cold, dry planet was once bathed in liquid water, the essential ingredient of life. Recently, scientists have found life on Earth in places they never thought possible before. Miles deep underground, beneath Antarctic ice, even in boiling water by deep-sea volcanoes, living on the chemical energy of sulfur instead of sunlight. Wherever they look, if there's liquid water, there's life. So if early Mars had water, perhaps it had life as well. But so far, attempts to find it have failed. And so have attempts to find proof that Mars really was wet.
The evidence that we should find, we don't find. We don't find the minerals that would suggest that there was lots of water around on Mars long ago. However, we do find the channels. So there's a contradiction. There's a question, what's going on this planet which has part of the evidence, but not all of the evidence?
To find the answer, Spirit and Opportunity will explore sites that look like they once had water and try to prove it on the ground. For Spirit, the science team chose Gusev Crater, which they suspect was once a huge lake fed by a channel the size of Grand Canyon. And on the other side of Mars, they chose Meridiani Planum, where an orbiter recently detected a mineral called hematite, which sometimes forms in contact with water. This is where Opportunity just landed.
That's the first time in the history of planetary exploration that a chemical signature on a surface of a planet of the type we were looking for, related potentially to water, was staring at us.
Now look at this one.
Look at this!
The first pictures are stunning. Just a few feet away from the lander is an exposure of bedrock, the first ever seen on Mars.
Holy smokes. I'm sorry, I'm just blown away by this.
Bedrock is the holy grail of geologists, a record of ancient environments carved in stone.
This is the sweetest spot I've ever seen. That outcrop in the distance is just out of this world. I can't wait to get there. I got nothing else to say, I just want to look.
When the full image arrives, they realize that Opportunity hit a cosmic hole-in-one, landing in a shallow crater.
We got lucky. I mean, we just got damn lucky. You know, Tiger Woods couldn't do this. We just went right into it. And so we're lying in the bottom of this crater, and the beauty of that is that the crater walls expose materials that we wouldn't otherwise see. I mean, there's this wonderful rock outcrop here. And if we were out driving on the plains, this stuff could be a meter beneath our wheels, and we'd never know it was there. Instead, because we fell in this crater, there it is.
The science team has been planning, rehearsing, and dreaming about this for years. Led by principal investigator Steve Squires, this all-star collection of geologists and planetary scientists is about to start exploring Mars in a way that's never been done before. Right away, they're confronted with something new. The rock seems to have fine layers running through it. Layers suggest the possibility that it's sedimentary rock, formed by the accumulation of sand or mud, perhaps on the floor of an ancient sea. Or it may just be hardened layers of volcanic ash. Volcanoes covered much of Mars in lava and ash billions of years ago. And until now, scientists have seen little evidence of anything else.
Most of the rock on Mars is volcanic lava flow. This is something else. This is an unusual Martian rock, at least compared to what we've seen everywhere else. The fact that these rocks are layered says that one possible origin for these is that they were laid down in liquid water. We do not know what's going on here, but the beauty of it is we have preserved in front of us a record that will answer that, and we have on our rover a toolkit of gizmos that will tell us that answer.
A week later, Opportunity rolls off the lander. They look for the hematite, the water-related mineral that drew them here in the first place. The infrared spectrometer, called Mini-TESS, can identify minerals according to how they absorb and radiate heat. A false color image shows lots of hematite in the red and orange areas, and very little where it's blue and green. The areas with the least are where the airbags left their imprints. Then, with the microscopic imager on the robotic arm, they take a series of extreme close-ups of the soil and find another puzzle. Tiny spheres the size of BBs litter the ground. A short drive forward brings the rover close to the outcrop. Another image, with the color tweaked to distinguish different materials, reveals more spheres. And more close-ups show them eroding out of the rock.
Embedded in this outcrop, like blueberries in a muffin, are these little spherical things. and they're really, really round, and we're trying to figure out what they are.
Just a few days into the mission, Opportunity has turned up evidence of something. But exactly what remains to be seen.
It's like a mystery novel, okay? You know, you read a mystery novel and you get fed these clues. And we're trying to piece these clues together. And right now we got a partial story, and I don't know how it's going to come out.
Spirit is ready to get back in the game. The engineers found that the problem was simply too many old files in the flash memory.
I'm sure Opportunity is thankful to Spirit for finding this problem, because they would have been there in about a week, and we would have had 2 rovers with, 15 stalls of debug.
When they're sure that nothing else is wrong, they delete the old files, pronounce Spirit cured, and chalk it up to growing pains.
The Spirit rover always seems to have been a bit of the trouble child. And it was just when all the attention was shifting away from Spirit to Opportunity, because Opportunity was going to land. It almost seemed like, a sibling that was trying to get attention back to itself.
But along with the good news comes the realization that Spirit was not as fortunate as Opportunity in its landing site. If this was once the bottom of a lake, geologists would expect to find the kinds of rocks and minerals that form in a wet environment. They sample a boulder and the soil near the landing site. But it's all volcanic and shows no sign of ever having been wet. The evidence they're looking for may have been buried, or it may have eroded away, or it may never have been there at all.
The rocks that we have analyzed appear to be basalts, the most common type of lava. And as a person who is really interested in lavas, this is fine with me. But it's a disappointment in a way for the mission, because we are after evidence that this really was a lake bed.
Maybe they can some kind of thing.
Natalie Cabral was one of the first to suggest, 15 years ago, that Gusev was once a lake. And she fought hard for its selection as one of the 2 landing sites.
I think we're on the right track. It's just like the evidence is going to pop out like it did in Meridiani, because we happen to land in front of an outcrop.
If the evidence of water has been buried, a good place to find it might be in the exposed walls of a small crater in the floor of Gusev. From Spirit's landing site, it's 300 meters to a crater they call Bonneville.
Bonneville might give us an interesting insight on what's underneath our feet.
It will take weeks to get there, but it's the best chance they have.
We're kind of grasping at straws here, looking for the right stuff. It's a tougher site, it's a harder site to love, but it's what Mars has given us. So,
back at Meridiani, Opportunity's team is ecstatic. They've spent the past week traversing the outcrop, creating a close-up photo mosaic. Now they're selecting targets for closer study.
I think we're all in Mars Geology 101 here. It's an experience where we look at the evidence and say, well, what could this possibly be? This is an alien planet, and we don't know what we're going to see when we get down close and personal with this rock. With each picture that comes down, there's really an expectation that you just might break the whole thing open.
If this outcrop was ever exposed to liquid water, there will be clues in the chemistry of the rock. And that's what Opportunity is looking for. The rovers have 2 spectrometers on the robotic arm. One can identify minerals containing iron. The other sees chemical elements. Both work by bombarding the target with radiation and reading the signal of what bounces back. Every element and every mineral has a unique signature. So far, the instruments have seen a lot of sulfur, a common chemical element in volcanic gas. If the gas mixes with water, it can make sulfuric acid, and that can react with certain rocks to produce mineral salts called sulfates. A lot of sulfates in this rock would be evidence of water. But the sulfur seen by the instruments may be just a thin coating on the surface. The only way to tell for sure what the rock is made of is to get a clean look inside. And the rovers have a special tool for that purpose, the rock abrasion tool, or RAT. But the man in charge of the RAT is worried.
I thought that before landing we had roughly been able to approximate anything that Mars was going to throw at us. Of course, what I neglected to think about was a rock that would be spitting out blueberries. What we're afraid of happening is that we're going to dislodge one of the spherules, and that it's going to be like a pinball machine between the RAT and the surface of the rock. And this could be something that causes us some problems.
Oh my God.
Squires thinks they're onto something big.
But what are we dealing with here? I mean, this rock.
Steve Gorovan's team spent years developing the RAT.
This does not look volcanic. This is not basalt.
There's not too many other things left.
Now the mission is riding on it.
Well, we're going to get to the bottom of it, so...
Yeah, exactly.
Literally.
And it's you who got to do it. Okay.
I will.
The science team selects a piece of the outcrop called El Capitan for Opportunity's first RAT. Squires shows the rover driver the area where they want to work. Then the driver builds a set of commands that will tell Opportunity exactly how to get there. Incredibly, considering that the rover is on Mars, he'll get it to within a few centimeters of the desired spot. Meanwhile, Gorovan has blueberries on his mind. He picks a spot to RAT that looks berry-free on a full-size image. But when the close-ups arrive, he gets an unpleasant surprise. More blueberries.
Look at this. You cannot see this berry in the place that we looked at. You just can't see it.
You got it properly registered with the pan can? You know where you are?
I did not see those spherules in the pan can.
Steve, sit down with some pan cam images and get this stuff registered. You got to figure out where you are, man.
I promise that's what Phil and Keel are doing. That's what we've been doing since I got here. But we can't find this. We're not at the
Well,
edge.
it's obviously there.
We'll solve it.
Solve it. Solve it by the science.
Hey, we get paid. We'll solve it.
Every day on Mars brings new problems, and they have to be solved quickly. The rovers wake themselves up each morning when the sun hits their solar panels, at which point they're ready to receive instructions for the day. But they're on opposite sides of the planet, so as day begins for one, it ends for the other. That means round-the-clock operations for two science and engineering teams, trying to take advantage of every waking moment for each rover. And there's another problem. The Earth day is 24 hours long. But the Martian sol is 24 hours and 40 minutes. Every day the rovers wake up 40 minutes later. And to stay in sync, the people on Earth must do the same. So if the day starts at 7:30 on Monday morning, on Tuesday it's 8:10. On Wednesday, 8:50.
This way, it's better.
A week later, it's 2:10 in the afternoon. And so on, marching relentlessly around the clock until everyone is in a state of permanent Martian jet lag. This is indoor work. Earth days and nights are blocked out. Diets tend to suffer. The primary food group is ice cream.
It's trouble. There's no doubt about it. It's definitely trouble. There's an excess of cookie dough piece pops consumed by this organization.
Mars time is especially tough on families. Cindy Oda is on the communications team. Her husband, Jeff Bizadecki, is a rover planner. Their work schedules change every day. But their two little girls, ages 3 and 5, live strictly on Earth time.
It still gets very confusing. Like, we're always trying to look at our schedule, trying to figure out what time exactly that we work and do we overlap, and also to coordinate with our children's schedules. You know, there's pickup time, their drop-off time, music class, and their swimming classes, and the, you know, ballerina class.
If we didn't have any Earth time at all, it would make things a lot easier.
It's the salt. This is 5 millimeters.
It's even tougher for those who try to keep up with both rovers.
They're both exciting. I like to go back and forth between the two. It takes real effort to force yourself to go home and sleep. It takes real effort to eat. But yet you don't want to miss anything. You don't want to say, oh my gosh, if I go home for a week, I'll come back and they will have figured it all out.
Yeah, we gotta go to this place and beat the hell out of it.
Each day is a race to absorb the new data coming down, and then, while the rover sleeps, to prepare a plan for the next sol that's ready to uplink the moment the rover wakes up in the morning. No one knows how long the rovers will survive, so every minute counts. At Meridiani, the pressure is on to choose a spot to rat on El Capitan.
That spot for ratting has to be chosen now. And I mean literally in the next, it should be chosen in the next, hour.
What is this rock?
That's McKittrick.
Okay.
Finally, his team picks a spot that looks safe.
You guys got to stay with me and do the uplink priority.
Then they build a step-by-step sequence for the rat grind.
McKittrick Base and Jim's Berry.
The plan gets worked over again by the full team, balancing science priorities with what the rover can handle. Every sol, every move they make on Mars goes through this same process.
With that as a starting point, let's go.
The engineers take the science plan and turn it into a string of commands the rover can understand. And by the time Opportunity wakes up in the morning, the command sequence is ready.
What a twisted knot in the stomach mode, first time using all.
In mission control, they'll have one last chance to check the rat's position before giving the final go-ahead to start grinding.
And now the fun begins.
If the rat is not correctly placed, it could malfunction. It's precision work. And on Earth, all they can see is a still picture and numbers on a screen.
This I can't stand this. I wish it was over.
That's good. Contact switch is tripped.
As far as they know, the rat is ready to go.
Are you ready to give a formal go for the rat sequence, Master? Yes, I think we are.
More definitive.
We'll go to rat. Go to rat. I like that. Okay. You are clear to command.
On my mark, 3, 2, 1, mark.
The rat has been engaged.
This is a childhood dream to be involved in a mission like this. I mean, literally a childhood dream. I feel highly responsible for this important little episode here. I don't care if we find chili under there. I don't care. I just want to make that thing work.
That evening, it's time for Opportunity to send back pictures of what it accomplished. And it does.
Right. My thumbnails. Damn. Bring them up. Eric.
It's a low-res close-up of the ratted hole coming in from Mars.
That is all the way through there. Look at that texture.
Oh, baby.
Yeah.
Oh, yeah. I'll take it. Yes. You see that hole? I heard the fall. Oh, crap.
Oh, man. Oh, this is huge. This is huge. It's beautiful, man. You did it.
Okay, well, next stop, Guadalupe.
It's the most important hole we've ever dug.
Now the spectrometers have a clean view inside the rock. What they see could clinch the water story, but it will take a few more sols to find out. At Gusev, Spirit is closing in on Bonneville Crater, and there's still no evidence of an ancient lake. But Mars is what Mars is.
I happen to really like the Gusev site because it's working class Mars. You know, it's the 98% of Mars. We went thinking we might find a lake, but what we're finding is lavas and dust and craters and impact processes and the winds blowing for eons. That is probably most of Mars. Gusev is just good solid, down-home Mars.
That could change when they see what's over the rim of Bonneville Crater. Exposed bedrock is what they're hoping for. But when the pictures start to arrive, it's not there.
Looking at that view right there, it looks like an awful lot of the same stuff we've been looking at.
Have you seen anything that would pass for outcrop yet?
Let's say it's an organized pile of rubble, as far as I can tell.
The hope is we'd see layers. And at least in that view right now, we don't see a lot of layers, but hope, still have our fingers crossed that they're in there somewhere.
But at full resolution, the most interesting thing at Bonneville is the remains of Spirit's heat shield on the far side of the crater. They'll spend a few sols exploring the rim, but there's no reason to risk driving into a hole they might not be able to get out of. A more tempting destination is 2.5 kilometers to the east, the Columbia Hills, which from a distance show hints of layered rocks that could be interesting. But it will take another 3 months to get there. Another long wait for the scientists.
Disappointed, maybe, but not to the point that, we are forgetting that the good stuff is all around us and more and better is to come.
It's at the same size scale as the other points.
At Meridiani, everything seems to be pointing to water. But they have to resist jumping to conclusions before all the evidence is in.
Anybody in the world can look at this data. The same data we're looking at right here is all available on the web. So there are some kind of frustrated geologists out there. They're wondering what's taking so long to figure out the obvious.
First, the blueberries. Nature has more than one way of making things round. An asteroid impact or volcano can spray molten rock into the air, where droplets harden into tiny beads and fall back to the ground.
Well, imagine if that's happening. Boom, a bunch of these things fall in. They're all going to be concentrated in one layer, right? We don't see that. They're dispersed.
Best guess is that they're concretions now, I think. Mm-hmm.
They think it's more likely that the berries are something called concretions, mineral deposits that grow in water-saturated rocks, like pearls and oysters. That's what they look like, but to be sure, they need to know what they're made of. The view of the spectrometers is too wide to measure a single sphere. So they zero in on a cluster where the view is mostly blueberries. And what they see is the signature of hematite, the water-related mineral that drew them to Meridiani in the first place. Concretions made of hematite are common on Earth. In southern Utah, they weather out of bedrock and cover the ground, just as they do on Mars. The hematite in the Martian blueberries is solid evidence that they are, in fact, concretions. This alone would make a strong case for water. But then comes the clincher. The long-awaited spectrometer data from the rat hole on El Capitan. The instruments say that the rock is as much as 40% sulfate salts.
That's beautiful, man. It's so different from anything that we've seen before. That's great.
There's no doubt what this means. The only plausible explanation for that much salt in one place is that it dissolved in water first, and then the water evaporated.
If you tasted this thing, you'd taste the salt. It's a very, very salt-rich rock. It looks like what geologists call an evaporite deposit. Evaporites form when you have liquid water with lots of stuff dissolved in it, and the water evaporates away and it leaves stuff behind. So salt flats. Go to the Great Salt Lake. Go to any place where you've evaporated away seawater, and you will find these salt beds. There's an awful lot of sulfate salt in this rock, and that's very, very hard to explain away other than water having been massively involved in creating this stuff.
One last piece of evidence would be familiar to anyone who's ever walked on the beach at low tide. Ripples created by the flow of water over loose sand. Over long periods of time, rippled sediments can build up and harden into stone. The water is gone, but the ripples are still there in the layered rock at Meridiani. Where the water came from is still unknown. But one possibility is that it came from below, as groundwater laced with sulfuric acid, percolating up through the volcanic bedrock, leaching out elements like iron, creating a broth of dissolved salts. At times, the water would flood the surface, forming shallow lakes or seas that would last for a while and then evaporate, leaving a crust of the dissolved sulfate salts behind. This may have happened repeatedly, building up a thick deposit of salty rocks over time. The hematite blueberries would have grown within these rocks while they were saturated with water. Now the water is gone, and the rock is eroding away, leaving the harder berries behind.
So we think we're parked on what was once the shore of a salty sea on Mars. That's pretty cool.
2 months into the mission, NASA is ready to tell the world what's been found. The first proof of liquid water on another planet.
Opportunity's latest science returns from Mars have profound implications for future exploration. And that's going to be the topic.
For centuries, people have wondered whether there was ever life on Mars.
A shallow, salty sea.
Now we've found one place, at least, where life had a chance.
We know that there was standing water there sometimes, but not all the time, for at the very least thousands of years. We also know that the planetary surface was dominated by the chemistry of sulfur. Does life live in that kind of environment on Earth? Absolutely.
There are microbes on Earth that thrive in sulfuric acid, and many species that use sulfur compounds as their source of energy.
If life were present on Mars 3.5 billion years ago, very likely some of that life could have figured out a way to tolerate the environment at Meridiani. Whether or not there was life present to take advantage of those conditions is still an unsolved question.
If life was there, the evidence is likely to be preserved in the kinds of minerals that formed at Meridiani. But to find it may take instruments more sophisticated than any that can currently be sent to Mars. So in 2013, NASA hopes to bring a few well-chosen rocks back to Earth. Between now and then, a series of new missions will make sure they choose the best possible rocks when the time comes.
Our strategy is to understand the big Mars, so when we look for life, we're not misled. Let's take this finding, Meridiani, and let's extrapolate it across the planet. Where else on Mars does it look like that? Is this the Holy Grail place to go look for life? Maybe there's better places. So we've got, for the first time, clear-cut direction.
They were expected to last just 90 Martian sols. But months later, the rovers are still at work. Opportunity climbs out of Eagle Crater and takes in the view. Billions of blueberries, formed in rocks that have long since eroded away. And on the horizon, the rim of a much larger crater called Endurance, where the water story of Meridiani takes on a new dimension. Exposed in the walls of this stadium-sized crater are massive outcrops of layered rocks. Salt-rich rocks like those in Eagle Crater, but a much deeper slice of Martian history.
There's meters of sulfates here. Okay, so a lot of water has to have gone away to leave that much salt behind. It's much more than we thought we were dealing with before.
Opportunity spent 6 months inside Endurance Crater, working out the details of the water story at Meridiani, which may span hundreds of thousands, if not millions of years.
And then there's Spirit, the long-distance traveler. On Sol 156, it's at the base of the Columbia Hills. 70 meters up is an outcrop of bedrock, the first they've seen in Gusev Crater. But it will be a tough climb.
This is one beat-up vehicle. This thing has traveled for 3 kilometers. It's coated with dust. We got a gimpy wheel. You know, that front right wheel is hurting. If it was a fresh vehicle, I'd say, yeah, we could climb this hill. As it is, it's going to be a struggle.
A month later, Spirit has beaten the odds and become the first mountain climber on Mars. And it's here that the rover finally gets lucky.
Orbital maps suggest this bedrock is older than the floor of Gusev Crater, and possibly older than any lake it may once have held. But the instruments detect goethite, an iron mineral that can form only in the presence of water. This may prove to be a different water story than the one Spirit was looking for. In any case, it will add a new dimension to our picture of Mars.
At Gusev, we get 2 different pictures. The rocks in the Columbia Hills can tell us something about very early events in Martian history. They also tell us that in the last 3 billion years or so, not much has happened. It's been cold, it's been dry, it's been quiet. Meridiani, wonderfully enough, fits into the interval between those things. So the whole history of Mars isn't this place or that place. They both show us a real Mars at different times in its history.
Days grow short as the Martian winter closes in. Solar energy fades, and the rovers are slowly starved for power. How much longer they'll last, no one knows.
There will be a deep sadness, I think, when they're gone. But when they do finally die, it'll be an honorable death, you know. Look at what they've accomplished. It's so much more than we expected from these vehicles. And it'll be a rough day, but I think we'll be able to look with pride on what they've done.
If life took hold on Mars as it did on Earth long ago, chances are it's happened other places too. Spirit and Opportunity have opened our eyes to a new world and moved us a step closer to answering the question, are we alone?
Next time on Nova, once hailed as the missing link.
He's not African, he's not German, he's British.
The greatest discovery of the 20th century turned into one of the biggest frauds in science.
The public was scandalized.
Who was behind it? The boldest hoax.
On Nova's website, join Steve Squires as he leads you on a visual tour of the Red Planet and relive the greatest discoveries made by Spirit and Opportunity. Find it on pbs.org. To order this show or any other Nova program for $19.95 plus shipping and handling, call WGBH Boston Video at 1-800-255-9424. Nova is a production of WGBH.